Okay, so we made our graph of Canada's population versus time, and we fit our linear model to it. And then we could use our model just by subbing in that value for year. So we did years since 1940, so x would be 79. And we got, when we sub our x value into that calculation, we got 37.67 million, which is really pretty close to the actual value of 37.59 million. So our linear model for the growth of the population was pretty good, right? Um, then we did our second fitting where we fit a nonlinear model or a power series to our infant mortality graph. So in this one, we wanted to identify the key trend. And so what we might say in words is what I've written up there at the top, is that prior to 1960, or x equals 20 on the graph, the number of infant deaths decreased linearly. After 1960, that section of the data that we chose to model, that decline accelerated. So what we see in that graph is that steep decline in infant deaths since 1960, with it leveling off towards the end. And then we made our prediction using that equation, subbing in our value of 78 for the year 2018, because it's 78 years since 1940, and we got a y value of 1.111. So this model predicts 1,111 infant deaths in 2018. Now, the actual number that I looked up earlier was 1,750 deaths. So this model isn't probably as good as our linear model was. So something else has happened since then that has caused that decline in infant mortality to level off somewhat. So we've ended up with more deaths than we would expect from this model alone. Okay. But this model still captures the broad features that we see in that graph. That steep decline early on, close to 1960 or close to x equals 20, and this flattening off as we get towards years 50 and 60.